Hi, welcome to the Slack Chat podcast number 5, where Stuart Winter, the maintainer and creator of Slackware ARM, joins me, Phil. My name's Exaga, and I'm the maintainer of the SAPI project.
Hi, Phil. How
Hi,
you doing?
Stuart. I'm very well, thanks. Yourself?
I'm all right in very windy and wet England.
Isn't it awful today?
Fence panels have blown down, and my next door neighbour's tree that is incredibly tall, about 4 times as tall as my house, is flexing itself, which is slightly concerning. but yeah, other than that, all good.
Yeah, it's certainly affecting me and my online abilities. I've had an outage this morning for no apparent reason, and I put it down to the weather.
It's definitely the weather, yeah. So
yeah.
Actually, I hope that this recording I hope it continues to work. My ADSL has popped off every now and then, even though I have a script, checks the PPPoE and if there's various different tests and then brings the whole stack back up again. That will hopefully keep everything in check, but let's hope the recording works properly.
Let's hope it holds up.
So where did you want to start today then?
Last podcast, we ended with the linuxdoc-tools, and I asked you a question. Why does it seem to be just a big box of separate packages?
Okay, so there's a little bit of history. When I was first porting ARM Slack, I needed to build the Slackware package that's called SGML tools. I looked at that package and I looked inside the Slackware source tree, and all that was really in there, if I remember rightly, it was just a collection of Red Hat binary RPMs. And it had this .build script. It was not a Slack build script. Off the top of my head, it would just take these RPMs, deploy them onto the operating system's file system. That was kind of it. So I looked at that and I thought, how am I going to build a package of that? These are binary RPMs. And not only that, SGML tools have been superseded by a package called linuxdoc-tools. Now, the old Slackware SGML package was actually a combination. It wasn't just SGML tools, it was SGML tools plus some other stuff. That's why it's a monolithic package, because it started that way in Slackware. I just went and found the latest sources of linuxdoc-tools and everything else that I needed to replicate what was in Slackware x86, but build it all from source. And then built that big build script just to really emulate what was already in Slackware, because I was porting it. And then I just said to Patrick, look, I built this for ARM Slack. If you want to use it, it's there. And he renamed the package in Slackware to linuxdoc-tools, because that's what the actual main package at the time was. And then the reason why it was a monolithic package was because the packages that were originally included in SGML tools, they had dependencies upon one another. And so whoever it was in the Slackware team previously had just packaged them all together in one big package, because it was the easiest way to just deploy it, as far as I could tell. Just bundle it all together. So even in now the linuxdoc-tools package as it is, the build order is purposive. You have to build it in that order and have a working package. So over the years, it's evolved to be a box set, or supporting various different types of documentation systems and tooling and things like that. It would be easier to break it up in some respects, but to be fair, most of the packages in there don't change that much. And it's, in a way, it's also quite nice just to have document stuff in one big package. So that's why it's a monolithic package. Actually, some people have sent myself and Patrick through the years a revision of that build script to turn it into a Slack build script, so that it doesn't build with my Slack packaging tool, which is a tool that's just do configure, make, install, and it tracks the changes on the file system and builds you a Slackware compliant package. But one of the reasons why it's still it's a .build script. It doesn't. If you just run that script on its own, it's not going to build you a package. You have to run it through the Slack packaging tool. And one of the reasons is because, to be honest, that documentation stuff is like a nightmare. It took so long to get it working, and because it's so complicated, I don't really know that much about the documentation tools. It creates catalogs, and it does also like XML catalogs, and it's just like it's like a different universe of stuff. So the thing is, what I'm saying is that to convert it into a Slack build script and make it clean, that it's all the scripts that people ever sent us as replacements didn't really give you anything. It just meant you didn't use Slack track, but in fact they installed everything on the file system anyway and just kept build sub packages and then build another package, install the sub package, but didn't really gain you anything because Slacktrack took care of all of that anyway.
Yeah. Okay.
And the other thing is as well is if you let the software install itself directly on the system, you actually know that what it's installed is how it's meant to be. Sometimes what you get with building packages, I guess not so much anymore, but certainly you still can find pockets of it, is when the dest dir parameters just didn't work properly. So you'd say, for example, you'd do make install dest dir equals some temporary place where you could package all of the content. And then what would happen is inside some of the binaries and other things, it would actually have the hard-coded absolute paths in there. So you'd package it all up, you'd run the thing, and it would try to refer to /tmp/package blah blah blah, but that path has got hard-coded into binary or into a part of the package. And so in linuxdoc-tools, because the stuff in there is just so complicated, it's actually easier just to let the thing install directly on the file system and then collect everything and then put it into a package afterwards. Some things are just easier to do that way. One of the things I also used to use Slacktrack for was building packages of CPAN modules. Because ordinarily when you do CPAN modules, you have to go and download if you want to package them up, you download the archive and then you do whatever the commands are to make a CPAN pack to build the thing. And then, but instead of doing that, I just thought, well, I've got an easy way of doing that. There's an actual CPAN shell that will go and fetch you whatever the latest version is. It will build it and test it and everything, and then it will install it onto the file system. So I just wrote a script that would go and handle the CPAN shell and basically make it install what I wanted, and then Slacktrack would come along, collect everything it put on the file system and turn it all into a package. I didn't have to go and download anything manually. I just got CPAN to do whatever was the latest version available and package it up for me, and I shipped it out to my servers when I used to work as a sysadmin. So I just used it to build a package really easily out of all of that kind of stuff.
The packaging article which you did, the PDF for Fosdem, I found it absolutely invaluable when I was trying to learn about Slackware packages, because I don't know who it was that informed me, but they said there is no other operating system in existence that makes making packages as easy as Slackware. And I'm thinking, well, Slackware's very much hands-on, and I can't imagine it being a simple procedure. So I went in search looking for information, and it led me to your PDF on Slackware packages. And I think I mentioned before that I've had no questions and no problems since I've read it. And if it can do that for me, who was completely uneducated and unaware of all things Slackware package, if it can do that for somebody like me, it can do it for anybody. It's very well laid out. It's easy to understand, and it's a perfect guidebook, if you will. I have a link for it on my browser, so if I ever need to go back and retrace what I've done or remind myself of information, it's quickly accessible.
Oh right, yeah, thanks. I've almost forgotten about that.
Yeah,
so
it is quite old. It's 2005. I don't know if you remember doing it. I'm sure
I definitely
you do.
remember doing it. Yeah, I definitely remember doing it.
What's the story behind that?
So Fosdem it's been around for a long time now, evidently since at least before 2005. So Fosdem is a European meeting. When I went there, it was in Brussels, and it's where open source hackers and a community get together and talk about the things that we're working on, the open source projects, the distributions, and there's lots of beer involved. But it's a really well run event, and I think it's at least 2 days over the weekend. And there's lots of breakout sessions. So what happened is that Fosdem wanted someone from Slackware to go and talk about Slackware packages, and they contacted Patrick, and he's in the US. And because I'd written Slacktrack and I've been working on ARM Slack, I should probably explain what Slacktrack. Essentially, Slacktrack it's inside of Slackware. It's in the D series. You can have a look at the description. It's pretty self-descriptive. Basically, it takes these build scripts and allows you to build Slackware compliant packages of In fact, linuxdoc-tools, that's an example. That's one of the best examples because that's the one that's still used. Go and have a look at that if you're interested in it. So I'd done that, and he said, could you go and do that because you know how the Slackware packaging system works really well. You can be the Slackware packaging expert. I said, okay. So I made this presentation, the one that you're referring to, which there's a PDF of the presentation slides, and the script actually is also there, talk track, and it's on slackware.com/tilde Moses, MOZES. I think you'll find it there. So I did that presentation, and I was looking at the scheduling because I was, some of the guys at Red Hat had done things like that before. One of the guys said, I really hope that your presentation doesn't run at the same time as like Alan Cox is talking, because Alan Cox was still in the Linux world at that time. Because can you imagine, like, if you have a presentation slot at the same time as a speaker that people have heard of, like how many people are going to come to yours? But I was quite fortunate because that wasn't the case.
Yeah.
So that was what that was about, and so there wasn't material around at the time about how to build Slackware packages. So people had been building them, but no one had actually collected together a set of standards and put them together in one place. So that's what it was about. It's about how the packaging system worked and how to build Slackware compliant packages. Because even Patrick himself doesn't publish any packaging standards. He never has done. He's got some, but they're not anywhere apart from in his head. And in your head, if you go and actually port the entire distribution and see what the standards are, because we talked, didn't we, on the last podcast, how Patrick does what he does, and I mean, I don't know, I haven't asked him, but after a while you do it for so long that, for example, I know that if I go and upgrade the device tree compiler package in Slackware ARM, I need to go and build a new kernel, or rebuild the kernel, because that exercises that package. I will know that whether it works or not, and in some cases it didn't. That's how I know. So and it happens, I've tried to automate that through the years so I don't have to remember as much, but that was what was going on there. So I went through and unpacked all of that stuff and built a presentation out of it, and it's a piece of piece of advocacy for the distribution itself. So I really like doing that, and I met quite a few different people there. They're really good events to go to if you're really interested in open source and want to meet some fellow developers. I haven't been there since doing it. It's a bit difficult for me to go now, but I definitely recommend going to those. On the packaging side, I think you're right. You might imagine that because Slackware's hands-on, it's quite difficult to build packages, but it actually isn't, is it?
It's wonderful. It's once, as with everything, it's like making a cake or riding a bike. Once you've got the basics, once you know what you're trying to achieve and how to achieve it, it is really simple. It's just a few steps, unbelievably simple, and so effective. I really do admire the way that it's put together.
So I can see what you mean now about why that document was useful, because it does tell you really what you need, like the ownerships, permissions, the anatomy of the package was I think was quite useful, wasn't it?
That's why I said if anybody's interested in building their own Slackware packages, they can't do any better than read that document, because it explains just about everything.
I was thinking about that. I haven't got time to update it. I don't even think it needs that much updating. It's just it just doesn't have some of the latest standards like it says. I think things have changed a little bit in Slackware, but not so much that it would. Well, I think it'd still be probably quite useful. I think so. In comparison to, say, building packages on other distributions, have you looked at how they're built on other distributions much?
Not at all. Yes, I have. Debian. I had to look into a Debian package once to fix something, and I can't even remember what the procedure was now, because it was many years ago, but I do remember it wasn't as straightforward as Slackware, and it was just one package.
Right. So I've looked at quite a lot of the packaging systems for the other distributions, the way that Debian build packages and things. I took some of the concepts from there and built my own versions of it for the ARM build system. So I got some really good ideas out of the packaging systems, but in terms of the simplicity, the package build scripts that are in Slackware x86, it is very straightforward, because it's literally a shell script, and you just run it and it builds a package. It's a self-contained. So it is very easy to build packages on Slackware. If you just look at some templates and those kinds of things, it is very straightforward. If you're going to be distributing packages, I think there's a distinction to be made between if you're distributing packages for someone else versus just having your own. You do need to be aware of what you're doing. using the right directory paths, making sure the permissions are correct, ownerships are correct, and stuff like that. Because I don't remember if this is the case anymore. I don't know if it ever changed, but for example, something had gone wrong in my build script, and it chmod 700. The package sudo directory, sudo root directory was /tmp/package-foo, and then you had user bin blah 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 whatever in there. And somehow my script had done chmod 700 on /tmp/package-foo, and in package tools you cd into it, run make package, and it made you a package. But it didn't tell me that top level of that package was chmod 700. So when I installed it on a range of machines, suddenly users couldn't log in anymore because the root directory it needs to be globally executable so they have access to it without being root. So there are, I'm not sure that's the case anymore. I don't remember. The Slackware ARM stuff takes care of all of that kind of stuff. I learnt my lessons, but I don't remember if make package does. It might do that kind of issue.
For those listening, chmod 700 is owner rights only. That means owner can read, write, and execute the file, and nobody else.
For root, yeah, in this case. So you can try, if you've got a system you can try it on, do chmod 700 / and it will stop your regular users logging in. So you do have to be careful about those things. But again, if you're going to make packages for Slackware, you need to look into it. You've got materials around there, so you've got the packaging of the slides of the slide deck, and there is also slackbuilds.org where there's lots of templates, build scripts for a whole range of different packages.
It's a plethora of packages on Slack builds. It's absolutely brilliant archive.
Exactly, yeah. There's a lot of work that goes into making that.
Yeah.
So it'd be good to talk to actually some of the guys about how they do that.
It would.
I mean, I know there's a mailing list and things like that. Well, yeah, we could talk to them about that. But again, it's something, if you want to go and make packages, you should read about how to do it and what the standards are. Have a look at the document I've done, and you'll get a good idea about that. I don't know if there is still another packaging document that is very similar to what I've done. You've got templates. Maybe the people have done that by now. I guess they probably have. I haven't looked.
I've seen a couple of articles on Slack docs about Slackware packages, but it's not in bits and pieces, but there's a few pages with little pearls of information on them, whereas your PDF document has it all in one place. So you don't need to go looking elsewhere.
That's good. Maybe at some point I could do a revision, a new version of that.
Maybe turn it into a HTML page or something.
Well, I've probably still got the original version of the document, but I think it was in Star Office format because that's what there was at the time. So yeah, that's about building packages. It is pretty straightforward. It's very straightforward to understand. You don't need to install lots of things. You just take a build script and run it. I suppose the easiest place to start if you wanted to look at it would be to look at the Slackware current, go and have a look in the source tree and just have a look at the build scripts. Most of them, they're more or less the same type of template. In the main, it is a case of running some kind of configuration script and then installing it into a directory and then copying some documents, putting some man pages in there, gzipping them, setting some permissions, installing the package description file and any post-installation scripts, and basically packaging it up. That's one of the things I do like about the packaging system in Slackware is it is the simplicity. I mean, you do get the fact that it is so simple in some respects can mean that you could say that it makes it difficult, but actually kind of it doesn't really. I think it makes it quite simple, and
it makes it easier, I think.
Yeah. As I said in one of the previous podcasts, you don't, even though you could have broken dependencies, it doesn't always matter. Sometimes it really can matter, obviously, because things just don't work. But that's one of the things I really like about it. It's got the tools to do these things, to allow you to upgrade to the latest set, allow you to install new packages. But at the same time, it doesn't really force you to do things in that way. It doesn't force you to go and install a whole load of stuff that you know that you don't need. So that's what I like. Actually, I've seen this a few times in somebody's signature on linuxquestions.org about Slackware. I don't remember exactly what it says now, but something along the lines of Slackware is not meant to be easy, or it's not easy. Right? And I think that's actually an untruth, because I think it is easy. So I guess it depends on easy for whom. To me, it's very easy to do what I want to do. I think a reframe is needed. It's not that it's difficult. for. When I started porting Slackware, there was certainly no documentation about how to port it, and all of the scripts were only for i386 at the time. I mean, they were hard-coded i386 target triplets in the build script. So you could never just run it on ARM, because it would try and go, well, I don't have a i386 Slackware GCC toolchain. Hence, one of the reasons why the ARM Slackware build system is completely separate. It had to be, because the original couldn't be used as it was. So it can be difficult, but back in the day there wasn't as much documentation, so I didn't see it as difficult. I thought it was just a challenge. And now there's so much more documentation. And actually, as you have said, if you want to spend time learning about how Unix works, how Linux works, I think Slackware is one of the best ways to do it, precisely because it doesn't force you to work within a very rigid structure. And that's actually one of the things I think it really completely sets it apart from other distributions. It doesn't tell you must go and install this dependency, and because you must do this and you must do it. Doesn't do that. It gives you a set of lightweight tools to manage the distribution, to ingest the new packages from the maintainers, to install them, to upgrade them. It gives you tools to build your own packages. They're simple things, but they're sufficient. And I think that's what I like it. It's a case of it's sufficient enough to be useful, as long as you're prepared to go and put some effort into it. But if you don't want to put effort into it, go and use a different distribution. If you want to go and spend some time learning about how Linux and Unix works, it's a brilliant place to start. Buy some relatively inexpensive ARM hardware and then install Slackware ARM on it. I think it's a great way to go and get deep into the guts of Linux and Unix, because Slackware allows you to go off pretty quickly off the track. But it never tries to bring you back. It never goes. It doesn't go behind your back and suddenly start deleting things, start wrecking things, which other distributions do. For example, I said to Patrick years ago, I said, because I'd been looking at Debian and some other stuff, and one of the things that they had was a script that goes and deletes the content of /tmp, which the temp directory.
Yes, I hate that. I know exactly what you're talking about. Yes.
It did it on a date basis, after say 30 days, it just deleted stuff.
Really?
And I thought I don't know if it's exactly 30 days, but some particular time frame. And I thought that was not a bad idea, particularly back in the day when machines didn't have so much disk space.
Yeah. And
Patrick wasn't at all interested in that, because you're doing something that the user's not the user of the system is not necessarily expecting. What if they wanted something left in /tmp? Yes, it's for temporary stuff, but if it's your system, maybe you're quite happy for it to be left there.
Wow.
And I really like that I would categorize that as it's a philosophy of no surprises. And I don't know if anyone else would, but it's one way of describing it. Let's not go and start doing loads of stuff behind the operator's back, behind the user's back. Let's give them this stuff. They can see what it is. Okay, we don't aim to solve every single possibility you could ever come up with when you're working on our system, but hey, here's enough tools to get yourself going. We are assuming that you want to go and learn and put some effort into looking at, understanding how how operating systems work, how to put things together. And here's a way of doing that. Here's a set of tools. Go ahead and do it. And even most recently with Slackware x86, if you look at Patrick's
Patreon,
I think it's Patreon. Yeah, you have your patrons of Patreon, and if you look at his description of what Slackware is, so he's evolved it a bit in the sense that that you can now start building it from scratch. You can rebuild the packages if you want. There's work gone into making it easier for the user to build the packages if they want to. The system now is you're able to build it from source, build the whole thing from source most of the time, whereas only a few years ago there were lots of packages that simply wouldn't build anymore. They did build when they were built, but they stopped building because the tool chain changed and various other, you just couldn't build those things without patching them. So Slackware has evolved in that sense, which I think further allows other people to come in if they want to start fiddling around with the package. If they want to see what happens if I optimize this, it allows you to do it.
Yeah.
I really do think it's such an easy system to use. If you take away all this stuff about it doesn't have dependencies, blah blah blah. You know what? That's really, really useful. If you want to just set it up on a cheap ARM device or put it in a virtual machine, you'll find that I think you can learn a lot more easily and quickly that way round. If you're really interested in it, I think it's a really great thing to use. That concludes episode 5 of this podcast. Tune in to episode 6 where we'll continue this conversation. Bye!